Hi everyone, welcome back to our channel. Today I am discussing grade 8 and grade 9 technology topic. I am here discussing some of the basic components of electricity, that means electrical components and their working, how it is connecting in an electric circuit. So these topics are common to grade 8 and grade 9 and we are learning in technology. So initially I am discussing the term current and voltage. Current and voltage. These are two familiar terms in our daily life. You are always hearing current, voltage related with the electrical appliances. So what is the relation between these two? You know that when voltage is more, current will be more. When voltage is less, current will be more. When voltage is less, current will be less. So the relation connecting current and voltage, this is current, that is represented by I, and voltage is represented by V. So the voltage and current relationships are like this. Voltage is directly proportional to current, or you can say when voltage increases, current increases. When voltage decreases, current decreases. You are familiar with that. If there is more voltage, you can see the brightness of the bulb is more. If there is less voltage, the brightness of the bulb is less. What is the reason? If the voltage is more, current flowing through the bulb will be more and it will produce more light. If the voltage is less, current flowing through the bulb is less and it produces less light. So voltage and current are proportional. That means when current passes through a wire, when a current passes through a wire, so current is passing through a wire or a conductor because of the voltage across the conductor. So across the conductor there is a voltage. Across the conductor there is a voltage. If there is no voltage across the conductor, there will be no current flow through the conductor. If there is more voltage, more will be the current flow. If there is less voltage, less will be the current flow. So voltage is directly proportional to current. So this symbol indicate what? Directly proportional. Directly proportional means when one increases, other will increase. When one decreases, other will decrease. So here voltage, when voltage increases, current will increase. When voltage decreases, current will decrease. So when you remove the proportional sign, you are getting a constant. V is directly proportional to I. When you remove the proportional sign, you are getting a constant. That constant is known as resistance. Resistance of the material. Resistance of the material, that is represented by the symbol R. That is represented by the symbol R. So what do you mean by resistance? You know that when current flows through a material, the material provides something to oppose the flow of current. The property of the material by which it opposes the flow of current. The property of the material which opposes the flow of current. And that property of the material, it is known as resistance of the material. From one material to another, resistance will change. You know that conductors are having less resistance. For example, iron, silver, the copper, they are conductors, they are metals. All metals are good conductors of electricity. So if a substance is a conductor of electricity, that means its resistance is less. For insulator, the resistance will be high. So resistance means what? It is the property of the material by which it opposes the flow of current. It opposes the flow of current. From one material to another, resistance will change. Metals are providing less resistance. Insulators are giving higher resistance. So resistance is represented by R. So the relation now becomes V equal to R into I. V equal to R into I. So V is representing voltage. V is representing voltage and its unit is volt. Its unit is volt. I is current. I is current and its unit is ampere. Its unit is ampere. And the symbol for voltage is capital V and symbol for ampere is capital A. R represents resistance. R represents resistance. And its symbol is, and its unit is ohm. And its symbol is like this. So these are the basic quantities related with electricity. Basic quantities related with electricity. Voltage. Its unit is volt. Its symbol is capital V. Current. Its unit is ampere. Its symbol is capital A. R. Resistance. Its unit is ohm. Its symbol is like this. So these are the basic quantities related with electricity. So you must learn this quantity and you must know which the units of the quantity. So from this you can get a number of relations. So V equal to R into I, or R equal to V by I, or I equal to V divided by R. So from this is a basic relation. This is a basic relation relating current, voltage and resistance. This is the fundamental relation. This is the fundamental relation that we are learning in electricity. And this relationship is known as Ohm's Law. This is known as Ohm's Law. Ohm's Law says what? At constant temperature, current flowing through a conductor is directly proportional to voltage. So if you state at constant temperature, current flowing through a conductor is directly proportional to voltage across the conductor. That means when temperature changes, Ohm's law will not valid. Ohm's law is valid when the temperature is a constant. So this relationship between the voltage and current is known as Ohm's law. So Ohm's law is one of the fundamental law in electricity. So Ohm's law says what? At constant temperature, current flowing through a conductor is directly proportional to voltage. So when you remove the proportional sign, you will get R. V equal to R into I, or R equal to V divided by I, or I equal to V divided by R. So these are the relationship. If you want to calculate resistance, you must divide voltage and current. If you want to calculate current, you must divide voltage and resistance. If you want to calculate the voltage across a conductor, you must multiply resistance and current. So from one numerical to another, the variables, the unknown will change. So these are these basic equations in electricity. And you are learning in grade 8 and grade 9 in technology. The same thing you are learning in grade 10, but some extended topic also. So in grade 8 and grade 9, you are learning only the basic concepts of voltage and current. When you divide voltage and current, you will get the resistance of the material. That is a constant for a material. Okay, so that is the property of the material. So from one material to another, R will change. So how will you calculate R, resistance? It is the ratio between voltage and current. How will you calculate current? It is the ratio between voltage and resistance. How will you get the voltage? It is the product of resistance and current. So these are the some basic relationship between voltage, current and resistance. So and this the law related with this. The law related with this is known as Ohm's law. How will you state Ohm's law? At constant temperature, current flowing through a conductor is directly proportional to voltage. That means what? If more voltage, more current. Less voltage, less current. Next I am explaining some basic symbols we are using in electricity. You know that cell, you are familiar with this term cell and battery. What is the difference between cell and battery? Cell is a single unit. Battery is it's a number of cells. More than one cell, it is named as battery. So you know that for a cell there is a positive and negative terminal. If you see a real cell, it looks like this. It looks like this. One end is plus, another end is minus. So in electricity we are using only symbols. So for a cell, how will you represent? Like this. This is a symbol of a cell. The longer line, it is plus, shorter line is minus. Don't draw like this, it is wrong. It is wrong. Longer line and there is a space and a shorter line. So longer line represents plus and shorter line represents minus. You can represent like this also. Minus plus. So this represents what? Symbol of a cell. So cell means it's a single unit only. And battery, how will you represent it? How will you represent battery? Positive, negative, positive, negative. Here now two cells. So it makes a battery. So this is plus, this is minus. If you are connecting like this is wrong. Here also two cells, but they connected negative of a cell to the negative of the other cell. It is wrong. Positive, negative, positive, negative. That means the negative of a cell should connect to the positive of the next cell. That is the correct way of connection. If you are connecting like this is wrong. This is a wrong connection. And if you connect like this also, this is also a wrong connection. Because positive of this cell is connected to the positive of the other cell. This is a wrong connection. So the correct connection for two cells, positive, negative, positive, negative. Negative of this cell is connecting to the positive of the other cell. Or the same thing you can connect like this. Negative, positive, negative, positive. This is also a correct connection. Here two cells. Here we are connecting two cells. Then this is a battery. If there are three cells, positive, negative, positive, negative, positive, negative. So this is plus, this is minus. So here we are having three cells that makes a battery. So battery means it's a group of cell, more than one cell. It is named as battery. So you learn cell and a battery. Here the cells we can connect in two ways. One is series way of connection. That means plus minus, plus minus, plus minus, like this. Here how many cells are here? 1, 2, 3, 4. Here the 4 cells are connected in series. What do you mean by series connection? Series connection is known as end to end connection. end to end connection. That means what? One end of a cell is connected to the other end of the cell. That means negative of the cell is connecting to the positive of the cell. It goes like that. So this way of connecting, this way is known as what? Series connection. So we can connect the components in two ways, which are the series. Another thing is parallel. So series connection means end to end connection. Series connection means end to end connection. That means one end of a component is connecting to the other end of the component. So that connection is known as series connection. If you are connecting three cells in parallel, how will you connect it? Second way of connection is parallel. Parallel way of connection. This is a cell, this is another cell, this is another cell. Here, the positive of the terminals of each cell joined at a point, negative of the each cell is joined at a point. This way of connection is known as parallel connection. Parallel connection means joining the ends. Joining the ends. Joining the ends. So here the three cells are connected in parallel. Positive terminal of three cells are joined at a point. Negative of the three cells are joined at a point. That's why joining the ends. It is completely different from series connection. So you can connect an electrical component, electric device in two ways, series and parallel connection. Series connection means end to end connection. Parallel connection means joining the ends. So these are the two ways of connection in electric circuit. Then you learned about resistance. You learned about resistance. Resistance is given by a resistor. Resistance is given by a resistor. Resistance is given by a resistor. What is the symbol of a resistor? This is the symbol of a resistor. So in textbook you can see this symbol. So this represents what? A resistor. This represents a resistor. So this resistor is giving a constant value of resistance. For example, 20 ohm. This resistance is giving a constant value of resistance. If the diagram comes like this, it is a variable resistor. That means it can give different value of resistance. So this represents a variable resistance. A variable resistance. So this is the symbol of different types of resistor. This is a exact symbol of a resistor. If it is a variable resistor, it looks like this. Variable resistor. Then, you know that in South Africa, what is the voltage you are using at home? The voltage you are using is nearly from 230 to 240 voltage. That is the voltage you are using at home. 230 to 240 voltage. Then, what is the frequency using here? It is 50 Hertz. Frequency of the electricity you are using, it is 50 Hertz. So, voltage normally you are using 230 to 240 voltage, and the frequency of the voltage is 50 Hertz. So, these numbers you must remember. We are using electric bulbs. What is the symbol of electric bulb? Electric bulb is represented like this. This is the symbol of electric bulb. This is the symbol of an electric bulb. So electric bulb is represented by this symbol. You know that electricity is passing through a closed path. If the current is passing like this. This is a closed path. If there is any break, the electricity will not flow through it. So there are two types of path for an electricity. For the electricity, there are two types of path. One is closed path. Another is open path. Closed path and open path. This closed path, how will you make it? Or open path, how will you make it? By using a switch. By using a switch. You know that different types of switches. So, open switch. How will you make open switch? What is the symbol of open switch? It looks like this. This is an open switch. You know that when the switch is off, the electrical appliances will not work. That means what? Electricity is not flowing through that path. And the continuous path for the electricity is known as circuit. It is known as electric circuit. Electric circuit. The electric circuit can be open or closed. So you can make an electric circuit open or closed. How will you make it? By using a switch. If the switch is opened, the circuit become, or the path become, if the switch is closed, the circuit become closed circuit. And if the switch is open, the circuit become open circuit. So for a closed switch, the representation is like this. Representation is like this. So electric circuit means what? It is the path. Along that path, the electricity is flowing. Along that path, the electricity is flowing. You can make that path open or close. How will you make it? By using a simple electrical component. It is known as switch. Switch can make a path open or closed. So open switch representation is like this. Closed switch representation is like this. So you can make an electric circuit open or closed by using a switch that can be open or closed. Then another electrical component. It is LED. You know this LED. That is light emitting diode. Light emitting diode. Its symbol is like this. Light emitting diode. Its symbol is like this. This arrow mark shows light is emitting. So you know the LED. It's a simple electrical component. It's a simple electrical component. It looks like this. It looks like this. So it has two legs. One is longer leg, another is a shorter leg. Longer leg is plus, shorter leg is minus. So how will you connect an LED in a circuit, or how will you connect an LED to a cell or a battery? How will you connect an LED to a cell or a battery? So this is the representation of the LED, and I am connecting like this. This is the correct way of connection. If you connect like this only, LED will glow. Otherwise LED will not glow. That means what? Positive of this cell is connected to the positive of the LED. That means longer leg of the LED. Negative of this cell is connected to the negative of the LED. That is the shorter leg of the LED. Then only it will glow. This connection is known as forward connection. Forward connection. So if I show like this, this is a LED. This is an LED. This is a cell. I am connecting like this. LED will glow. I connected to the longer leg, this is the shorter leg. So I am connecting longer leg of the LED to the positive terminal of the cell, and the shorter leg is connected to the negative terminal of the cell. That way of connection is known as forward connection. Then only the LED works. If you connect like this, LED will not glow, and this connection is known as reverse connection. In this connection, LED will not work. So you are familiar with the LED. You can see LED, small LED and big LED. It is available in the remote. It is used as a sensor. It is used as an indicator. So you can see different types of LED in different electrical appliances. So this is the way how to connect the LED in an electric circuit. Then another electrical component, it is rectifier, or it is known as diode. It is simply a diode. It is not light emitting diode, it's simply a diode. So a simple diode is represented by like this. This is a diode. Where we are using this diode? We are using this diode. You know that our laptop charger and mobile charger, you are taking a voltage of 230 or 240 from the connection. From the connection you are taking 230 voltage or 240 voltage. But the laptop and the mobile, the phone working with low voltage. So rectifier, diode is one of the component we are using in the adapter. So what it is exactly doing? So a diode converts high voltage to low voltage. High voltage to low voltage. High voltage to low voltage. So this is used in a phone charger or laptop charger. So the main function is what? Main function is, actually there are two types of electricity. One is AC, another is DC. That is alternating current and direct current. Alternating current we are using at home. Direct current from where you are getting? From a cell or a battery. From a cell or a battery you are getting direct current. At home you are using all electrical appliances at home. It is working with alternating current. Direct current you are taking from a cell or a battery. So mobile phone charger or laptop charger, they works with DC, direct current. They work with DC only. They work with DC. It will not function with the alternating current. So a diode is doing what? A diode is converting alternating current to direct current. Alternating current to direct current. And that's why it is known as rectifier. So rectifier means it's a device which converts alternating current to direct current. And the process is known as rectification. So which electrical component is doing that job? It is a diode. It is done by using a diode. So the process is known as rectification, which is done by a diode, and the diode is known as rectifier. So in a phone charger or in a laptop charger, we need direct current, but we are getting alternating current. So alternating current is converting to direct current by using a diode, and that process is known as rectification. And the component used is diode. So diode is known as a rectifier. So There are two types of current, alternating current and direct current. Alternating current, you can see almost all electrical appliances works with alternating current. Almost all electrical appliances works with alternating current. The kettle, the refrigerator, fan, grinder, almost all devices works with alternating current. But our phone, laptop, they need direct current. So we have to convert alternating current to direct current. How you are doing it? By using a rectifier, that is a diode. That's a diode. By using a rectifier, you are converting alternating current to direct current, and the process is known as rectification. And the component used is diode, and it is known as rectifier. Another electrical component we are using in different electrical appliances is transistor. Transistor. A transistor has two legs. A transistor simply looks like this. Sorry, a transistor has three legs. A transistor has three legs. It is named as emitter, base, collector. The three legs of the transistor is named as emitter, base, collector. These are the three legs of the transistor. A transistor is a small, simple electrical component. It has three legs and they are named as emitter, base, collector. Then what is the function of a transistor? A transistor in a circuit we are using for amplification. For amplification. So a transistor is known as amplifier. A transistor is known as amplifier. So amplification means what? Strengthening a weak signal. Strengthening a weak signal. For example, if my sound is very faint sound, if it is a faint sound, you can make it a loud sound. So a weak signal is strengthened by using an amplifier. So in an amplifier circuit, which is the main part, which is the main component, transistor. A transistor has three legs: emitter, base, collector. A transistor has three legs: emitter, base, collector. So this is used for amplification process. Amplification process means what? Strengthening the signal. That means a weak signal you can make as a strong signal by using an amplifier, and the process is known as amplification. So transistor is another component we are using in a electric circuit. Another component we are using in electric circuit is capacitor. Capacitor. A capacitor has two legs. A capacitor has two legs. The symbol of the capacitor, it is like this. It is not like this. This is a symbol of a cell. It is wrong. It is a symbol of a cell. The symbol of the capacitor is like this. That means the two lines are same length. The two lines are same length. So in the transistor, I forgot to explain the symbol of a transistor. The symbol of the transistor is like this. This is the symbol of a transistor. This is emitter, base, collector. This is the symbol of a transistor. And this is the symbol of a capacitor. If you are drawing like this, this is wrong. The two lines should have same length. Then capacitor is used for charging electricity. It is used for charging electricity. Once it is charged completely, it will discharge. It will discharge. For example, if you connect a capacitor to a cell, what will happen? Charges will move. Charges will store here on one plate. This is another plate. So charges will accumulate here. So the function of the capacitor is to store the electric charges. To store the electric charges. When it is completely charged, what will happen? It will discharge. It will discharge. That means it will send out the charges. It will send out the charges. So capacitor main function is to store electric charges. To store electric charges.